Some left. Now, yesterday we talked about removable discontinuities. Removable discontinuities are discontinuities that can be removed through algebraic processes, and therefore the limit exists even though the function doesn't exist, so they look like a hole on a graph, okay? With the strategy, the algebraic strategy we looked at yesterday to remove the discontinuity was factoring. Today I'm going to share with you the other two algebraic strategies, which is rationalizing and simplifying complex fractions. We will not be doing the third bullet today, okay? So, let's proceed. Wait. Would you guys write this down, please?
Hey, take off your jacket, dude.
All right, guys. I'm going to show you guys some stuff that'll help you with this. So let's review some things first of all. What is x minus 3 times x plus 3?
X squared minus 9. X squared minus 9.
Good. So these are what are called conjugate pairs. They're identical. It's just that one's a positive and one's a negative. And when you have conjugate pairs, you multiply the two first things together, you multiply the last two things together, and you get a negative. That's not usually how you multiply binomials, right? Usually there's a third term that pops up when you actually do the first inner outer last. But these ones, conjugate pairs, we could just do the shortcut, first times first, last times last, put a minus in between, right? So that's one thing you want to be aware of. Here's, it's like the opposite of a difference of squares. Hey, Zeke. I'm good. What's up? Okay. So here's another thing I want to review with you guys real quick. What is the square root of x times the square root of x? Right? When you multiply a square root times itself, it's just that number or whatever, right? What's the square root of x minus 3 times the square root of x minus 3? It's x minus 3, right? That's it. The root just cancels itself out. Okay? So what if we put these two ideas together? What if I gave you guys this? I say, what's the square root of x plus 2 times the square root of x minus 2? What's the answer going to be?
X minus 2.
X minus 4. Because this times this is x, and this times this is negative 4, right? All right, let's take it up a notch one more time. What if I said x plus 5 minus 3 times x plus 5 plus 3? Good. So that one times that one gives me x plus 5, right? And then that one times that one gives me minus 9. And as a final answer, I can say minus 4. Yeah? Okay. We good? All right, so now that we reviewed that, that'll make life a little bit easier. Does anybody feel they would like to practice one on their own without me doing it before we proceed? All right. Let's do it. Okay. Now, you don't need to write this, but I'm going to demonstrate something to you. Direct substitution is what we always try first. But if I do direct substitution, I'm going to get 3 plus 6, which is 9. And the square root of 9 is 3. And 3 minus 3 is 0. So I have a 0 on the bottom, which means we can't do direct substitution. So now we need to see, is this a removable discontinuity? Can I somehow get rid of that discontinuity? Well, factoring is not going to work. These aren't factorable things, are they? So hence we have our new strategy, which is called rationalizing. And it's what we just did. What I'm going to do is I'm going to rationalize this. That means cancel out the square root, but really it's just going to put the square root somewhere else, but that doesn't matter. By rationalizing and canceling out the square root, it's going to open up a possibility for me to maybe remove the discontinuity. So in this case, my radical's on the bottom, right? So what's the conjugate of this thing? Plus 3, right? So let's write this again. But this time we're going to put on the bottom the conjugate. We're going to multiply the bottom by the conjugate. You're right. Whatever we do to the bottom, we need to do to the top. Okay? Now, the bottom is what we practiced, so I'm going to pause here, and I'm going to let you guys work the bottom out, okay? Go ahead. I want the nice, final, simple answer for the bottom. You got it yet, Ricardo? What you got?
X plus 6 minus 9, and then we add the 6 and then x minus 3.
There you go. The nice, simple, final answer is x minus 3. When you multiply these two, you get x plus 6. When you multiply these two, you get minus 9. And then when you combine those, you get your minus 3. So it's x minus 3. Okay? And at this point, notice how I got rid of the square root on the bottom. It's on the top now, but it doesn't matter. Austin, what are we going to do now? There it is. And there's my removable discontinuity. I just removed it. Now I can plug 3 in with direct substitution. So, I'm going to go this way. The limit, as x approaches 3, of the square root of x plus 6 plus 3, you can put it over 1 if you want, but we're ready to do our direct substitution. What would that give me as a final answer? Yeah, 6 is it. Good. All right, and that's called rationalizing. Good stuff. Good stuff. Clear? Okay. All right, let's do this one together. So go ahead and write it down. So I'm going to ask Marcos. Marcos, what am I going to multiply in the top and the bottom of this thing?
X plus 4.
That's a great guess, but it's not. So I'm going to, that's good, because it's not always the bottom. It's the piece that has the square root. You want to try again?
Radical x plus 2.
There you go. So we're going to do radical x plus 2 on the top and bottom. It's the piece that has the square root. That's the one that we're going to do.
I think it was valid because 4 minus 4 is
0. Oh. Okay, that's an interesting way of looking at it. Okay, so now I'm going to ask Jade. Jade. What do I have on the top then, Jade? Yeah. Hello. Cool. Thank you. Jade. Not sure? Okay. Let's try Brandon Barr. What goes on the top, Brandon Barr?
x minus 4.
That is true. Because the square root of x times the square root of x is x, and negative 2 times positive 2 is negative 4. All right? The bottom we're going to leave the same. We don't need to multiply that one out.
Yes, you carried them.
Next, I'm going to ask Juliana if she wanna tell us what we can do.
Ooh.
And we've removed the discontinuity. Nathan, What do we do now? Yep, after you remove the discontinuity, you can just plug in your number. And I'm going to ask Alyssa if she will tell us the final answer then.
1/4.
True. We've removed the discontinuity. Even though this function doesn't exist there, it does approach a limit of 1/4. All right, so now I would like you guys to try this guy. Angelisa, what do we multiply to the top and bottom? Okay, this is the most common mistake I've seen in here today, so make sure you look. It's +1, not -1, okay? That's what you put on the top and bottom. All right, so now if I do that on the bottom, Ashley, what would the bottom become if I multiplied that? It would become x minus 5. Okay, because the square root of x minus 4 times the square root of x minus 4 is x minus 4. And then -1 times +1 is -1. And that makes -5.
Oh.
Okay?
What? I got x minus 60. I think you multiply the 44.
Yeah, you don't do that.
You can do that.
Yeah.
You multiply a radical by a radical, all you're doing is canceling out the radical.
Fall back.
Why is it x minus 5 on the bottom?
From the work I just showed up here. So this times this makes x minus 5.
On the bottom. On the top, you just don't multiply like that.
Do you want me to explain it again?
So isn't it just 1 then? X minus 5 is x minus 5.
You're right. You're right. You got it though? Yeah.
That's the reason why you get it on the bottom.
All right. Let's talk to Andy here. Andy, what's next?
Where are we at? I don't let me, I saw it. Cancel the x minus 5.
The x minus 5s go away. Christian, what's next? You plug in your limit. Final answer, Samantha? 2. Good job. So that's another way to remove a discontinuity. It's called rationalizing. So we've learned 2 now, factoring, and now we know rationalizing. Factoring is when you have polynomials, because we could factor those. Rationalizing is whenever you have square roots, right? That's when you'd want to use that strategy. Let's talk about one final strategy. We're going to talk about this one. Oh yeah, there's that one. That's not technically an algebraic strategy, but it's a calculus strategy, and it's super easy, and it pretty much does every problem for you, but we'll get to that in a few days. For now, we're still doing algebraic strategies. So one more algebraic strategy. Go ahead and write this down. So this one's gonna confuse you if you don't pay attention, and it's not a bad one, but it's a little confusing. Okay, so these are called complex fractions. A complex, yes.
I was gonna guess. So you do the bottom like how we did before. You solve the bottom first, and then you go back to the top like the folding. So basically, you do this twice in one problem. In this one.
No, it's a different strategy.
I think what you're saying would work. I'm going to show you a different way. But I think if what you're saying is what I think you're saying, I think it'll work. Okay. So first of all, we have a complex fraction. The way you deal with complex fractions is by simplifying them, making them not so complicated. So a complex fraction, like I said, is when you have fractions inside a fraction. So these little guys here, these are the ones that are causing me trouble. These are the ones that are making it so that I have fractions inside a fraction. So what I'm going to do is I'm going to get rid of those. So here's how we're going to do it. Let's rewrite it really quick. We have limit x minus 2, x over, etc. Now, these are the two guys that are causing me trouble. So what I'm going to do is I'm going to turn this into not a fraction anymore. So what I'm going to do is I'm going to multiply it by its own denominator. So I'm going to multiply this by 2. Okay? And what that's going to do is that's going to allow me to cancel that. Is that a fraction anymore? But you're only allowed to do that if you do it to everything else. That keeps your fraction balanced. So if I multiply this by 2, I need to multiply this by 2 and this by 2. Every term in the top and every term in the bottom, that keeps your fraction balanced. So now that we've done that, let's rewrite it again. And after you guys get kind of used to this and good at it, you won't need to keep rewriting it. You could probably just do a few steps in one. But in the beginning, I highly recommend showing your work carefully. So now I've made my complex fraction a little less complex. I've made it a little simpler. But we're still not done. What do I want to get rid of now? That's supposed to be a 2. Let me make it a little bit clearer. Make sure you guys have that right on your notes. That's a 2. So, but I want to get rid of this, right? So I'm going to multiply that fraction by what? I'm going to multiply it by -2 plus x, which allows me to cancel those out, right? But if I do it to that piece, I have to do it to every other piece. So I need to put -2 plus x over here, and I need to put -x plus 2 here. Did I write that right? I didn't. -2 plus x. There we go. All right. Now let's rewrite it again and see what we have now. We have limit. We have x approaching 2. And on the top, I've got this. On the bottom, I have 2. Right? That's all that's left here is 2. And then plus, over here, I've got 1 times -2 plus x, right?
Shouldn't that be -2 plus x on the top?
Oh, I did it again. You're right. Mr. Bailey. There we go. All right, now this is a great time for me to talk about algebra do's and don'ts. I bet some of you guys right now be really tempted to go like this. That's an algebra don't. Well, let me tell you why that's an algebra don't. Don't you guys agree that when you have this, you get b, right? Do you know why that is? Because this is multiplication. And this is division. And division cancels multiplication. But, so that's a happy situation. But this is illegal. Because division does not cancel addition. Okay? And that's what we have here. These two things are being multiplied, but this is not being multiplied with anything over here. So what you have is you've got a times b and then an a plus b. So you can't be crossing stuff off there. That doesn't work. Okay? So what we need to do is we need to simplify the bottom a little bit. So let's do that. Let's simplify that up. So the top I'm not going to change. I like that because it's multiplication. I'm just going to leave it. You could distribute, but I think it will actually cause more harm than good if you do. So don't. Just leave it like that. But let's do the bottom. I'm going to distribute the 1, which is just going to give me -2x plus x, -2 plus x, right? And then what's the bottom become? Just x, right? Because the 2's cancel. Now, what else can I do? We can cancel that x out, can't we? The x's cancel, right? Now in this case, I removed something, right? But that wasn't a discontinuity. If I plug in 2 for x, will that make 0 on the bottom? But that's okay. It doesn't matter. Let's remove it anyway. Because actually, usually that's the thing that gets removed. So let's do it anyway. All right. So we have the limit as x approaches 2, and I'm left now with this. Right? So now that we've removed the discontinuities, there's no more discontinuities, right? Just plug it in. What's my answer? 0. Okay, so let's do a guided practice. Can I erase? All right. All right. Go ahead and write down this one. So I'm going to ask Ryan Wirt, what shall we do? Okay, go ahead and multiply the top by 3, and then I'm going to ask you guys what you got. Go. I'm going to ask you what I write right here. Let's see. All right, so here we go. Brody, what did you end up getting after you did that?
Well, subtraction. So you can't do it right away.
Did you do it, or? Okay. Let me see if Jennifer, no, go ahead.
3 minus 1 times 3x over 3x times 3 plus x.
Now, can you tell me how you wrote this after the 1? What did you write?
Parentheses 3 plus x.
If you guys didn't put this, you probably got it wrong. If you kept going. And what's on the bottom, Jennifer?
3x parentheses 3 plus x.
So here's where it is. If you guys don't use those parentheses, you're going to forget that you're distributing a -1. Okay? And so what that's going to end up looking like then is what's going to be on the top? Final answer. Distribute, combine, simplify. -x.
Negative X?
Yep. Because you get 3 minus 3 minus x, the 3's go away, but you are left with a -x. So you got to watch out for that. Use those parentheses. Chris, what would I do next? Get rid of the x's first, yeah. And now I have the limit. Well, I guess I don't need to write that again. Pretty much just crossed it off. All right, let me ask Zach, what's now?
Now, after you cross it out, you plug in 0.
Yep. So, Angelis, you were close. Maya, what's the final answer? Well, Maya, are you with us?
Yeah, I'm with you.
What's the answer?
What's the answer?
Yes.
I'm gonna tell you the answer. The answer is -9 plus 3x.
No, but that's okay. Good try. Nate, what's the final answer? -1/9. So we have it. The big error there is watching out for those negatives and distributions with parentheses and simplifying. You also want to make sure you're not making that math mistake over there on the board where you cross off things that are being added rather than multiplied. You guys see I wrote up there by the word calculus. Watch out for that error. Those are the most common things I see people doing. So let me throw one at you guys here to do completely on your own, and after that we'll call it a day. Why don't you guys do this guy here? Go for it. We're going to be stopping it there. I had more to this lesson.